Let's work with a few easy diagnosed, easy fungal syndromes to diagnose. The first one is ergot alkaloid poisoning. In summer, it causes summer syndrome, it's hypothermia. And in winter, the same fungus causes fescue foot because you get vasoconstriction caused by these ergot alkaloids. And in summer, because of the vasoconstriction, you get hypothermia. And in winter, because of the vasoconstriction, you get dying of the extremities. So any seed-bearing plant can be infected with Claviceps purpurea. Any seed-bearing plant. And here you can see them on annual ryegrass, macroscopically even. There are the ergots, and these are the normal seed heads. So you can see them quickly. Look at that as well. Here's the ergots of Claviceps purpurea, and it produces ergotamine, which is a vasoconstrictive agent. And this was a case in the Free State in dairy animals where teff was contaminated with this yellow nut setch, geel eentjie. This is what a normal geel eentjie looks like. And this is what an infected one looks like with these ergots. Claviceps cyperi, it's just another claviceps. Okay, you can see them even macroscopically. And they produce these ergot alkaloids, which are vasoconstrictors, and this is what you get. Heat stress, severe hypothermia. So think about this. If you see animals, heat stress is a huge problem in dairies, less so in South Africa compared to other parts of the world. But if you see this, keep this in the back of your mind, that this animal is overheating, and look at the feet. And sometimes, like I say, you can even see these things macroscopically. And they follow strange behaviors. They would like to cool them down and walk into dams to cool them down. You get a severe drop in milk production, and you can even diagnose this in a lab by testing what enzyme in the blood? Prolactin. This toxins, they inhibit prolactin, and you can test the levels of prolactin in the blood, and there you can diagnose or confirm your disease. This is what it causes in winter because of the vasoconstriction. Just for interest's sake, these little dairy animals, you get a drop-off of the extremities, all because of dry gangrene, vasoconstriction, fescue foot. Okay, those are the ergot alkaloids. Not too difficult to diagnose. Getting back, I'm interrupting myself now to give you an example of what fungi can do and how you can manage a case. This is now a case report that I'm going to discuss with you. I was called out by this farmer who also owns a feedlot, and in this silos there were maize, white maize for human consumption. Just next to the silos, there's the mill here that produces maize meal for human consumption. And during the rainy season, both these silos had a leak in there. And this is 6 million rands worth of maize in here. That was a complete cake of fungal growth. So the maize was stuck together. We couldn't even take them out with these augers. It was a complete cake of maize that was brown. And we had to cut open these silos with angle grinders on the side and took out the maize with spades. Remember now, we had to cut them open here. We took about 6 million rands worth of maize, completely damaged by the fungus or a fungus. So what was my approach in this case? So obviously, all the clever people said, throw it away. We took about 6 million rands worth of feed here. Obviously, you can't use it for human consumption. So I took a sample and I sent it to that institute that I told you about, the Plant Protection Research Institute. I said, look for me, what fungi are we working with here? And they isolated about 8 fungi. And that's what you can expect if you have heavy fungal growth. There will not be only one fungus, there will be several. I looked at these fungi And I said there was Aspergillus, but not a known toxic one that produces known toxins. And there were several, and none of them were known to be toxic to me. I've also sent samples to the OVI and to other labs to test for the toxins that we were able to test for in South Africa. And we couldn't find high levels of any toxin. So I told the farmer, he's got a feedlot feeding about 10,000 animals. So I said, let's try something to see if we can utilize this feed, 6 million rands worth of feed. So I said, take 3 animals in your own feedlot, and let's feed them for 2 to 3 weeks with this moldy maize and see what happens. That's the risk we took. So after 3 weeks, I phoned him. I said, so how are the animals doing? Are they dead or not? So he said, they're doing very well. I'm feeding this to 10,000 animals. And I got the fright of my life because he didn't follow my instructions to wait for 3 weeks. He started immediately. So you can imagine if there was a toxic fungus in there that was not even known to us scientists at the moment, he could have killed all those animals. But this is how farmers sometimes work. And these animals, he told me, has never produced so well ever before on this moldy maize. So that's a point I made before. Sometimes they produce proteins. So it's the best these animals has ever done in a feedlot, feeding severely moldy maize brown. It was white maize that turned completely brown into a cake, solidified by fungus. I'm in fact busy with a little project. I'm growing now some of these fungi and to see if we can improve nutrition on certain rations with fungi. So this is how you can approach a case like that. They were advised by Plant Protection Research Institute to dig big holes and throw it away. Now we've put it through animals and they did very, very well. Okay, let's talk about aflatoxicosis. Aspergillus flavus and parasiticus. There has never been a diagnosis made in South Africa on an adult ruminant about aflatoxicosis. Remember that. The Americans put a bit of emphasis on aflatoxin. The rumen detoxifies aflatoxin extremely well. They have different conditions in America where they take cottonseed and they put them in these silo bags, high moisture, high temperature, and they get levels of up to 500 parts per million of aflatoxin, and then it can override the detoxification capacity of the rumen, and they get aflatoxicosis. We've never found that in South Africa, so it's not a ruminant problem. Remember that. Okay, where is the problem? In monogastrics. This is a reported case of aflatoxicosis in pigs, and it's commonly known to be immunosuppressive in broilers. And if you want to use your toxin binders, use it in these animals. So just to show you, you can't generalize. The ruminant and the rumen detoxifies aflatoxin to a very great extent. I said they find up to 500 parts per million. Remember, how do we measure aflatoxin? In parts per billion. That's how toxic aflatoxicosis is. Aflatoxin is. So forget about aflatoxin in ruminants, except when there's very unusual farming practices, like putting cottonseed into silo bags where the levels can go up very, very high. Okay, another fungus that is very well known to us is called moldy corn disease. Look at all these fungal growth on maize. Fusarium verticuloides, again, not important in ruminants and never been diagnosed. It affects horses and causes holes in the brains of horses. Leukoencephalomalacia. This fungus being highly toxic to horses, not toxic to ruminants. It detoxifies the fumonisin, which is produced by this fungus. Diplodia. You will not find diplodiosis in a ration that was mixed in a dairy. It's a paralytic syndrome, but it's found on harvested maize lands. So if you've got heifers or cows grazing on harvested maize lands, which is infected by diplodia fungus, they will become paralyzed. And the difference always for me between There's the fungus. It usually starts at the base of the cop and it progresses to the top. And it's a disease of harvested maize lands. We found these crops. It's a paralytic syndrome. Animals that go down, and if you can remove them from these toxic maize lands, they recover. The recovery with diplodia is fairly good. That's always for me the distinction between botulism and diplodia. With botulism, they die because they can't swallow. With diplodia, if you feed them and give them water, there where they are, 90% of them recover. That's diplodia. There's an animal that where we induced, everything that I've talked about, we induced at the OVI. Everything that's in your Tox handbook, we induced and experimentally created. And that's where all these slides come from. And eventually they become paralyzed with diplodia, but they can still swallow, they can still eat, and they can still drink. Now here's a serious fungus. To me, one of the most important fungi in South Africa and worldwide, Aspergillus clavatus, marookvergiftiging, sorghum beer residue poisoning. Aspergillus clavatus likes to grow on substances that has been used to produce something else, like sorghum beer. And there's what sorghum beer residue looks like. It's widely fed in dairies and in the feedlot industry. And sometimes, or not sometimes, always, except if it's had been mixed, you can see these fungi. It's a blue fungus. Let me tell you, if you see a blue fungus, run away. It's Aspergillus clavatus. It's most probably the most toxic fungus that I know of. And it tends to grow on brewer's grain, but also this has become fashionable again to grow these seed trays in these moisture rooms. It's a nice place to grow fungi. And if you see, if I can get this cursor right, look at the blue fungus on these maize kernels that is grown in these hot houses and fed to animals. That's pure Aspergillus clavatus that you see there, the blue fungus. And this is what it causes. It's an unknown tremogenic mycotoxin. To just show you, we've known Aspergillus clavatus for so long, we still don't know what the toxin is. So please go back and go and study mycotoxins. All you need to know what this toxin is. It's very interesting. It's highly toxic. And it causes a tremogenic syndrome. What does that mean? Animals shiver. All their muscles show muscle tremors.
Dr. Neil, I've got a question here.
Yes.
From Alwyn Krause asking, can aflatoxins cause mortalities in ostriches?
Mortalities in ostriches, well, being a monogastric animal, yes, they will be more susceptible compared to ruminants. Ruminants, for me, it's a no-no. But I would think, again, the nice thing about aflatoxin is we can detect it, we can culture the fungus, we can detect the toxins and even quantify them because there's a test kit available for that. So yeah, if you've got liver damage, immune suppression in ostriches, send your sample away for aflatoxin analysis. And there are certain levels that are prescribed, not for ostriches, obviously, but for poultry. I think it's 30 parts per billion that are permissible according to Act 36. So yes, remember, and I'll come to your last slide, the toxin is in the dose. That's the law of toxicology. The toxin is in the dose. So if there are low levels of aflatoxin, it's going to cause nothing. Very high levels, it will cause mortality in ostriches and immune suppression. But comparing to this toxin of Aspergillus clavatus, we don't even know what the toxin is. We can't chemically analyze for that or quantify it because we don't know what it is. But with aflatoxin, it's well known and you can quantify it. Beautiful. Send in your samples if you suspect aflatoxicosis at high doses. It will definitely affect ostriches. It affects all monogastrics. It affects humans. It's the most potent carcinogen that we know of. Causes liver cancer. That's why I don't eat peanut butter, because they like to grow on peanuts, Aspergillus flavus. And Yeah, so it affects humans. It's the most potent chemical carcinogen causing cancers in humans is aflatoxicosis. It will definitely affect the ostriches at a certain level. So get it analyzed. Let's get back to Aspergillus clavatus, Maruk poisoning, hypersensitivity, severe central nervous system involvement. Look at this, dairy, which fed brewer's grain, Maruk. And to me, this knuckling over of the fetlocks joints is almost pathognomonic. If you can remember, what does that mean? It is, if you see that clinical sign, there's very few other things that causes that, except maybe a spinal abscess or some other funny thing. But if I see this in an animal and that was fed brewer's grain, 90% of time I would make a diagnosis of Maruk poisoning, Aspergillus clavatus. And you'll see now why. If you look at the pathology, look at the severe necrosis in these longissimus dorsi muscles in the back. Look at this white necrosis. There's a bit of normal muscle. Look at this. Severe muscle damage. And it also causes damage to the upper motor neuron. So take out that spinal cord and send it in. This Maruk poisoning, about a year ago, we had a case in a feedlot. We had emergency slaughter of 800 animals over a weekend because they were busy dying of Aspergillus clavatus. So this is a serious mycotoxin. Let us summarize the mycotoxins, and this is your take-home message. There are certain mycotoxins and mycotoxicosis that are clear and easy to diagnose. They are associated with specific pathology, like you can see here in front of you. And even aflatoxin, you will get liver damage. The ergot alkaloids, you will see hypothermia. So these are known fungi that causes specific syndromes. Then there are a whole group of fungi that we don't know a lot about. But get your fungal analysis done by the plant protection unit and get your toxin analysis done by a lab that can analyze for the few toxins that we can analyze for in South Africa. If you are serious that these animals, everything else is right, this must be a fungal thing. The animals are not doing well. Their feed intake is bad. They are immunosuppressed. Then we need to do this whole exercise of fungal analysis, toxin analysis, and remember, lastly, do your own little feed trial. The farmer will gladly accept your offer to do a feed trial. You can't send it to anybody else. Do your own little feed trial. Say, okay, we suspect this whole bunker of silage is now moldy. Is it really toxic or not? Send it in for fungal analysis to plant protection unit. Analyze, but they are not. These funny syndromes and test, things like T2, deoxylevarinol. You can test for that and we can quantify. For the rest, we do a little feed trial on the farm to see on animals that are maybe not as expensive and valuable, and we do our own little feed trial. Let's put these 3 calves on this moldy bunker of silage and see how they do, and let's do a little control group with not moldy silage, that kind of thing. You need to follow a practical approach with these things. To summarize, just don't make a diagnosis of moldy feed and you don't know what you're talking about. Follow it up, send in samples, do your own little feed trial, follow it through. I guess there will be lots of questions about fungal poisonings in the end. Let's finish off. We've only got 25 minutes left of about a few other syndromes in the dairy industry. Gossipol. Now, I always have a battle with the pathologists. They hate me and I hate them. They're very funny people. They like their patients dead, so they all screwed up anyway. But, with Gossipol, we feed up to 2 to 3 kilograms of pure cottonseed or cottonseed oil cake in dairies in many parts of South Africa. So to me, if you want to make a diagnosis of gossipol poison because it's a hard poison in dairy animals, you need to know what you're talking about. And let me tell you one thing that you can take home message as well. There is no correlation between cardiac pathology and cardiac function. If you look under the microscope, because that's what they do, these pathologists, they say there's cardiac damage, so it must be ONF4 or gossipol, one of those things. The heart can be pretty stuffed up under the microscope, and it functions 100%, and vice versa. It can look pretty normal, 100% normal, and the animal could have died of heart failure. There, the best two examples are gifblaar and top. Both are cardiac poisons. You don't see any pathology, but the heart has stopped beating. It's dead. So there's no correlation between cardiac pathology and cardiac function. So be aware. I don't discount gossipol poisoning in ruminants at all. It can happen. But again, test for the levels of gossipol in that specific oil cake, or because we've got different strains of cottonseed. Some come from Zambia with high levels of gossipol in it, and you get bound and free gossipol, and you can test for that. But yeah, that's the cottonseed, sometimes just fed as it is or as an oil cake. Fantastic food, hell of expensive, but very good stuff. Again, a problem of monogastric animals. Don't feed that to pigs. They will die of heart failure. Okay. In ruminants, we feed up to 2 to 3 kilograms per animal per day. So make sure about your diagnosis. Okay, remember our little diagram in the beginning. What animals are exposed to? Roughage, grazing, concentrates, most probably infected by fungi. Now we're at the feed additive stage. And there are a couple of important ones. You can forget about the last ones because we don't feed Zolmax to dairy animals. I hope not. But we do feed iodophores. Rumensin, Munensin is registered for dairy animals. As far as I know, it's about the only one. But we get 6 registered, only 5 now. And that is meduramycin was taken off after it caused secondary poisoning in the chicken litter, which we researched. But Munensin of Rumensin is one registered for dairy animals. What are the iodophores used for? Mainly as a coccidiostat in broilers, as a growth promotant in all species, and it prevents, and that's why we use it in ruminants. It prevents, to a large extent, acidosis, bloat, dairy animals, ketosis, good stuff. The iodophores to prevent ketosis to a large extent, and acute bovine pulmonary edema and emphysema. Okay, that's what are used for. As a group of substances, iodophore antibiotics is absolutely fantastic. We use them in the feedlot industry. We can't work without them. We use them in the broiler industry. We can't live without them. And to some extent, not all dairies use them, but many of them do. But I can tell you as a group, I've never seen more tragic poisonings in my career than with the iodophores, where they've made just a mixing error. And they've included by 10 times the level than what it was. Then you get all sorts of mortalities, all sorts of pathology, and there's a huge species differences. Horses are extremely susceptible. The rule of thumb is you never feed cattle feed to a horse. You can do it vice versa. But I was involved in the first horses that died under the jockeys on the racetrack when they fed feed containing seleniumycin. Bovine, there's the toxic dose, LD50 for cattle, 25 milligrams per kilogram. But yeah, good stuff. When do they cause problems? If they feed to the wrong species like a horse, or if they make a mistake at the feed mill, which often happens, and they've made a mixing error and the levels are too high. So you get these Dr. Van Dijk was involved in a long case, and there was a court case where I was involved in, where the level was supposed to be 20 parts per million, and the level was, say, around about 80 parts per million of rumensin in that feed. And that becomes a very gray area. It's not a clear-cut case like 400 ppms. And that's where the toxicologist comes in, because even if it was elevated and above the recommended level, did it really kill the animals? Or did it really cause this loss in production? And that's often very difficult to deduct from the analysis. And let me tell you, if you are involved in an investigation like this, the high courts are busy. There's a 3-year waiting list trying to catch all the criminals in this country. So a court case with a quantum, that's the money value of more than 200,000, goes to high court. So it comes onto my table what you did in your investigation 3 years down the line. And then I see what samples were taken, what pathology was done, and how the diagnosis was made. And I just get the dossier on my table. I am totally independent. And I look at the scientific facts, because I've seen experts trying to win a case for a specific party, whether it's a claimant or the defendant. You'd never do that. You give your professional and scientific opinion. You don't try and win a case for your client. You don't do that. But I see the cases, and I are sometimes in the unfortunate position that I sit in court opposite one of my colleagues, and I have got the file in my hand, the examination on this case that he did 3 years ago. And that is, to say the at least, sometimes embarrassing. So if you need help, phone a friend. Please do that.